Welcome to Power System class. Today we're going to cover single-phase composite transmission lines, and of course we are going to analyze the total inductance, the effect of the transmission, one of the effect of transmission line. So let's write down the empirical equation of the inductance. So 2 into 10 to the power minus 7 ln GMD over GMR. GMD is the distance between go and return circuit, which is A to D, B to E, same as E to C. These distances are actually the GMD, and GMR is actually the distance between individual go and the return circuit. Indeed, of course, the individual distance also important for this calculation. Let's start with GMD. So GMD we're going to calculate. So let's write down the value of M for go circuit and N for return circuit. What is the value of N? 2. There are 2 cables or conductors, D and E for return, and for go there are 3, A, B and C. So it has to be written for the empirical equation for GMD. So M cross N square root. So the value of M cross N is very important to write down the distances here. So here value of M is 3 and N is 2, so it will be 6 square root of. So under the square root will be 6 different distances, as here the value of 6. So the very first distance from A to D and B to E, these are same distances. That's why we have to write down 2 together within a square. So the distance is 9, so it will be 9 square. Now it's time to determine the value of BD and CE as well as AE. These are equal in distance, so AE is equals to BD is equals to C of E. These are equal in distance. And if you consider, here is a right angle triangle similar for other 2 distances. So this is the right angle triangle. So the distance of CE, the hypotenuse, is equals to square root BC square plus BE square, which is 9 square. So this will be 6 square. So we'll find the distance of 10.81 meter. So this distance, and this one are same and similar. So it will be 10.81 whole cube, as there are 3 distances. So how many distances we have to have? That is 6. So 2 and 3 gone, so 1 more distance remain. In this ironical point, let's have a different color pen. So which distance we require? So from C to D, this distance is required. And of course this is the hypotenuse for the right angle triangle AC and D. And what we need? We need CD distance. So CD is equals to square root of distance AC, which is 12 square, and AD means 9 square. What we have? We have 15 meter for CD. let's plug in the value of 15 here. So all the 6 value we have the distances. So after the calculation, we'll have is equals to, the value of GMD is equals to 10.74 meter. So we have GMD. Now it's time to calculate GMR. Now it's time to calculate GMR, geometric mean radius. Indeed, within this circuit, go and return portion, of course, there are 3 cables for go. Each of the cable are equal in radius, that is 2.5 millimeter. And here for return, the radius of this 2 individual conductor, that is 5 millimeter. Okay. And here actually 3 conductors or cables. Here are 2 cable and conductors, which is very important to determine the value of GMR. By the way, for GMR within a circuit, this go and return we have to calculate differently. Indeed, first of all, let's calculate GMR for a circuit. So the equation will be 3 square, because here are 3 cables, that's why, and 3 square means 9, so 9 square root, and here will be 9 different distances, right? So let's understand the distances. As I said, this is GMR, so radius is very important concern. So each of the conductor, so A, B and C, all of these 3 are equal. So this is the conductor, and the radius said 2.5 millimeter. So the individual distances for this stranded conductor R prime is equals to e to the power minus 1 by 4 times the radius of R. Why e to the power minus 1 by 4? Because all of these 3 conductors are made by solid materials, and the value for e to the power minus 1 by 4 is equals to 0.7788, and radius is 2.5 millimeter, right? So we have from this value 1.947 millimeter, or 10 to the power minus 3 meter. So there are 3 conductors, that's why we have to write down 1.947 into 10 to the power minus 3. As all these distances are in meter, that's why we are taking in meter. So there are 3 cables or conductors, that's why here will be 3 value. So 1, 2 and 3. So these 3 are equal, that's why same value, and to the power 3 means there are 3 cables. As I said, here will be 9 different distances, so 3 gone, so more 9 need to be write down. So distance 1 from A to B, 1, and then B to A, which is 6, again B to C and C to B, all are 6. So there are 4 distances actually, that's why 6 to the power 4, right? Again A to C or C to A, there are 2 distances, which is 12. 6 plus 6 is 12, so 12 square. After calculating, we will have the value 0.48 meter. And for the return, G, M, R, B, how many conductors here? 2. So 2 square, and here will be 4 different distances. As here 2 conductors, and of course these 2 are equal in radius, and the radius is 5. So the individual strands or individual distance R prime is equals to e to the power minus 1 by 4, and the radius, which is 5 millimeter. So we'll have the value 0.0034 in meter. Now let's plug in here. It should be 4, and 2 cables means 0.0034 whole square, and another distance from D to E as well as E to D, pardon, that is 6. So 2 distances, 6 square. We'll have the value 0.1529 meters. So GMRB is this one, GMRA is this one. So we almost have done. Now it's time to calculate the total inductance. L is equals to 2 into 10 to the power minus 7 ln GMD over GMR, right? So GMD we have 10.74 meter, and GMR we have got two. One is GMRA, another one is GMRB. So this is considering GMRA, and this is actually GMRB, which is 0.1529 meter, of course. So let's find out the value of LA for conductor 1. So indeed 2 into 10 to the power minus 7 ln, and GMD are common for both circuit A and circuit B, I mean go and return. So this will be 10.74 over 48. So L of A will have 6.2 into 10 to the power minus 7 Henry per meter. Same as for LB, equation will be 2 into 10 to the power minus 7 ln GMD 10.74, and GMR for B circuit is 0.1529 meter. We'll have here 8.5 into 10 to the power minus 7 Henry meter. So altogether the total inductance for the circuit, so total L equals to LA plus LB is equals to 6.2 into 10 to the power minus 7 plus 8.5 into 10 to the power minus 7 Henry and meter. Altogether the value is 14.7 into 10 to the power minus 7 Henry per meter, or we could write down 14.7 into 10 to the power minus 4 Henry per kilometer.